Welcome to SPT online classes, and today we are going to solve some problems from Kirchhoff's method. So I have few problems over here, so there is no meaning in explaining a lot of theory. Just let's get into problems straight away, and let's find out the easiest method to calculate these problems. So from the as the first problem, I have taken a very simple circuit where it contains a voltage source and we have a resistor. So how will we solve Kirchhoff's problems using a simple method? Let's find it out. So in the first problem, let's take the current as in the clockwise direction. Okay, this is what we are going to follow in every single problem, that I'll be taking current in the clockwise direction. Okay, let us name it as I. And always remember the Ohm's law, which is V equal to IR. V equal to IR. Okay, this is what you should always remember, because Kirchhoff's law is an extension of Ohm's law, especially the second law. Okay, now what we are going to do, I'm moving the current, or I'm taking the current in the clockwise direction, right? So when we move clockwise, if you're finding the voltage source negative end, okay, when you're finding the voltage source negative end, then you have to put plus V. Okay, now check, is there any other voltage sources in the same circuit? If nothing else is there, then put an equal sign. Then since we are taking the current I, right, I, and there is only one resistance in this particular circuit, so multiply with R. Okay, so according to the given problem, it is plus 1 volt equal to current into resistance, which is 1 ohm. Okay, 1 volt equal to I into 1 ohm, that is I equal to 1 ampere, and that 1 ampere is moving in the clockwise direction itself. Since it is positive, the direction which we have taken is correct, which is clockwise itself. So this is the method what we are going to do in the remaining problems. In every problem we are going to take current clockwise itself. So I hope you got the technique. Let's do the second problem. Okay, in the second problem, let's take the current as usual in the clockwise direction. So let me mark it as I, and let this be the source voltage, and let this be the resistance R1, and let this be the resistance R2. So how will you write the Kirchhoff equation? Moving in the clockwise direction, you are seeing the negative end of the source. So what did I say? You have to put plus V. Okay, now further moving forward, you can see the resistor R1 as well as resistor R2, and the current flowing through these two resistors is I itself. So there is no other voltage source, so put an equal sign, then I into R1 plus I into R2. So if you know the values of R1, R2 and V, easily you can find the value of current. This is how you do the second problem. The next problem, third problem, once again we are taking the current in the clockwise direction, but this time when you move in the clockwise direction, you are finding the positive sign of the battery. So what you have to do is that you have to put minus V. Minus V, is there any other voltage source? No. So put an equal sign, then moving forward you see the resistor, so I into R. Okay, thus you get I equal to minus V by R, that is, in this case it is minus 1 ampere. What does this indicate? What does the negative value of the current indicates? It indicates the actual current is flowing not in the clockwise but in the anti-clockwise direction. The actual current is flowing in the anti-clockwise direction. So you don't have to bother about the real direction of the current initially. Initially you can take in every case as clockwise, and you can move forward with the problem, and in the end, if you are getting negative, that indicates whichever direction you have taken, that is not the real direction of the current flow. It is actually the opposite direction. That is all what the sign is indicating. Okay, let's try the next one. How will you try this problem? In this question, we have 3 sources and 2 resistors. So let's once again take the current in the clockwise direction. So current I'm taking in the clockwise direction. And while I'm moving in the clockwise direction, I see the first voltage source and I'm seeing the voltage source negative n. So as usual, let me write it for easy purpose, like 3 voltage sources V1, V2, V3 and 2 resistors R1 and R2. So how will you write the Kirchhoff's equation? Here you can write it as, since you are moving in the clockwise direction and you are seeing the negative end of the source, so let's write it as V1. Further moving in the clockwise direction, you see a resistor, but keep that resistor for the time being. Let's jump into the next voltage source, because first we will deal with all voltage sources. While you're moving in the clockwise direction itself, you can see the voltage source V2 with its positive end. Okay, so you have to write minus V2. Again, moving forward, you can see another resistor, keep it there itself, and again you can see another voltage source with its negative n. So what you have to do, if you are seeing the negative n, you have to write plus V3 equal to now you can take the resistor. So at this time, let's take the resistor R1. The current flowing through it is I, so I times R1. The second resistor is R2, current flowing through it is I itself, so I times R2. Understood? This is how you should write the Kirchhoff's equation. Understood? So let's try another one. You can solve it by simply substituting the values for V1, V2, V3 and R1 and R2 values. You can calculate the value of I, which is not a big deal. The big deal is how to write the equation. Okay, now let's do this one. Fine. In this question, how will you write the Kirchhoff's equation? Okay, for that purpose, in order to make it once again easy, I am writing the names V1, R1, V2 over here, R2 over here, V3 and R3. Now here we have multiple loops. So in one loop, let's take current as I1 moving in the clockwise direction, and the other one, or second loop, let me take this one as I2. Okay, now how will you write the Kirchhoff's equation? Let's take the first loop. First loop means it starts from here, then just focus on these 4 dots, 4 nodes. The loop within that 4 nodes is our first one. Fine. Moving in the clockwise direction, you are seeing the positive end of the source, and so you can write minus V1 since you are seeing the positive end. Then again, the next source is over here. While moving in the clockwise direction, you are seeing the negative end, so plus V2. Is there any other voltage sources in the first loop? No, so you can put equal. Fine. Then taking the resistor R1, moving in the clockwise direction, it is I1 only flowing through R1, so I1 times R1. Understood? Now while moving clockwise direction and taking the resistor R2, this is where you have to be very careful. So while moving in the clockwise direction, when you take resistor R2, 2 currents are flowing through that R2. One is I1 in the clockwise direction through the loop 1. Okay, I1 is flowing in this direction through the loop 1, and the other is I2 flowing in the clockwise direction through loop 2. And since we are writing the equation for loop 1, okay, you have to give importance to I1. So how will you write? You can write plus I1 minus I2 into R2. Understood? This is how you should write the equation for loop 1. When you write the equation for loop 2, let's see, loop 2. Moving in the clockwise direction, you are seeing the negative end of the voltage source. There is only one voltage source. So V3 plus V3. Okay. Any other voltage source? No. So put an equal sign. Now if you take the resistance R2 then the current flowing through that R2, there are two currents actually, which is I2 and I1. But since you are writing the equation for loop 2, you have to give importance to I2. So I2 minus I1 into R2. Now, is there any other resistor? Yes, we have R3. So how will you write the equation for R3? You have to write plus I2 R3. Why? Because there is only one current flowing through that R3, which is I2. So I2 R3. Understood? Now you can solve these two equations, equation 1 and equation 2. Equation 1 and equation 2, you can solve it out and find the value of I1 and I2. We will definitely solve few circuits till the end, but I am just now showing you how to write equations. Once you know how to write equation, then we will get into the solving part. Okay, this is how to do this problem. Fine, now let's increase. Okay, let's expand the circuit. By the end of this video, you should be able to solve Kirchhoff's equation in any manner if the question is asked. So here in this particular circuit, let's name it. That's the first thing we have to do. That's the first thing we are going to do. So let's name it as V1. This one, let's name it as R1. Okay, let's name this one V2. Here we can call this one V3, this one R2. Okay, R2. Here we have another resistance R3. Okay, be very careful with naming. And here we have a resistor which is V4. Correct, V4. Here we have a resistance V5. Okay, here we have a resistance R4. Here we have a resistance V6. Okay, so we have 6 voltage sources and altogether 4 resistors. How can we write the equation, Kirchhoff's equation? So I'm just minimizing, okay, over here so that I can write it on the right side. So let's take 3 loops. Loop number 1, I1, clockwise direction. Loop number 2, I2, clockwise direction. Loop number 3, I3, clockwise direction. Okay, take loop number 1. In the loop number 1, when I move in the clockwise direction, I am seeing the positive end of the source, which means minus V1. If you move further, you can see another voltage source with negative end, so plus V2. If you move further, you can see another voltage source with negative end, so plus V3. In the loop 1 itself, all these are coming. Once again, that is V5, okay, that is V5, it's not V3, it's V5. You have to be careful, yes. Moving the clockwise direction, you can see another voltage source with negative and so it is plus V3. Understood? So 4 voltage sources are there. Now anything else is there? No voltage sources, so put an equal sign. Now let's take the resistive terms. Moving clockwise direction, the current flowing through resistance R1, that is only I1, right? So I1 times R1. Again, is there any other resistance? Yes, we have a resistor R2 here, and the current flowing through R2, be careful. See, I1 in the clockwise direction, I2 is opposing it. Since we are writing the equation for loop 1, how will you write? Plus I1 minus I2 into R1. Is it R1 or R2? R2. R2. Understood? So let me write it clearly. Yes, R2. Okay, that is how you should write for loop 1. In the loop 2, if you move in the clockwise direction, you can see the positive end of the source. So you have to write minus V3. Okay, then if you again search for voltage sources, once again you can see a positive end of another voltage source which is minus V4 equal to, there are no other voltage sources, so put an equal. Looking at the resistive terms, you can see resistor R2 current flowing through R2 will be I2 minus I1 into R2, because two currents are flowing. Since you are writing equation for loop 2, you have to give importance to I2. Okay, and one more resistor we have R3, but through R3 only one current is flowing, which is I2. So what you have to write? Plus I2 times R3, plus I2 times R3, because only I2 is flowing through that. Loop 2 completed. Loop 3, if you check loop 3, moving in the clockwise direction, you are seeing the positive end of the battery, so 1 minus V5 minus V5. Again moving clockwise, you can see another voltage source with its positive end, so minus V6. Any resistor? Yes, we have a resistor R4, so equal to I3 times R4. So you can pause the video for a second to check these equations, and after that let's move to the next question. So you can substitute values for voltage sources and resistors, and you can solve for I1, I2, I3. As I said, we will definitely do few solving problems, but these are problems just to show you how to write equations. I hope you understood this one too. Okay, now let's find out the answer for this problem. Answer for this problem means we are going to calculate the current through each resistor. That's how this question will be coming for your exam. You have to find the current flowing through 6 ohm, 3 ohm as well as 2 ohm. So what we are going to do is that we are going to follow the same steps. So let's take the first loop as I1, current flowing through first loop as I1, and the current flowing through second loop as I2. Now what do we do? Let's concentrate the first loop. Moving clockwise, you are seeing the negative end of the battery, so you have to write 8 volt. Okay, now we are doing it numerically. Now if you move further clockwise, you can see another source with its negative end, so plus 6. Got it? Now there are no other voltage sources, so put an equal sign. Let's take the resistor 6 ohm. The current flowing through it is I1 alone, so 6 times I1. If you take 3 ohm resistor, then current flowing through it is I1 and I2. Both currents are flowing, so you have to write plus I1 minus I2 into 3. The reason is because I1 is dominating, since we are writing it for loop 1. Now that's the first equation. This is the first equation. Second equation, so you have to concentrate on loop 2, where moving in the clockwise direction, you can see the positive end of the source, so you have to write minus 6. Once again another source with positive end while you are moving in the clockwise direction, so minus 2 equals, you take the 3 ohm resistor first, current flowing through it is I2 minus I1. So 3 into I2 minus I1. We have one more resistor which is 2 ohm. We have a 2 ohm resistor, current flowing through it is only I2, so plus 2I2. This is the second equation. Now let's rearrange the first equation. Let's reduce the first equation. What will you get? 8 plus 6, 14, which is equal to 9I1 minus 3I2. Okay, reduce the equation number 2, you will get minus 8 equals minus 3I1 plus 5I2. Understood? Now you can find out the values for I1 and I2 using different methods you prefer. You get the answer as, while solving that, you get the answer as I1 equal to 1.27 ampere and I2 equal to minus 0.833 ampere. What does that indicate? Whenever you are getting a negative answer, that indicates the direction of the current actually you have chosen is wrong. The current is flowing in the opposite direction which you have chosen. So I2 is not flowing clockwise, I2 is flowing anti-clockwise. That is all what it indicates. So let's take resistor 6 ohm. What is the current flowing through each resistor? Let's find it out. Current flowing through 6 ohm, it's only I1, and I1 is positive also. So current flowing through 6 ohm is in the clockwise direction, and the value is I1 value is 1.27 ampere. Current flowing through 3 ohms, through 3 ohm, if you check, we already got I2 as negative. So the actual direction of I2 is not clockwise, it is anti-clockwise. So both I1 and I2 are flowing through the same direction. So current flowing through the 3 ohm is in this direction. So what will be the value of that current? It should be the sum of the magnitudes of I1 and I2. Understood? That means you have to add 1.27 plus 0.833. Why? Because we already considered the direction. Now you don't have to put the negative, and the answer for the current flowing through 3 ohm will be equal to 2.103 ampere. Got it? Now what is the current flowing through 2 ohm and the direction of it? Current flowing through 2 ohm is only I2, but we know that the actual answer of I2 is negative 0.833 ampere. So the direction of current flowing through 2 ohm is not clockwise but anti-clockwise, which means in this direction. Understood? Hope you are getting. And the answer will be, the current magnitude will be 0.833 ampere. Now let's see the simulation of this particular circuit so that we can verify these answers are correct. So you can pause this video for a second and write down the values of the current flowing through each resistor so that you can compare with the simulation. Okay, let's see that. Can you see this simulation? Here you can see the flow of currents. Okay, let's concentrate the 6 ohm first. 6 ohm, what was the current? 1.27 ampere around, correct? We got that answer itself. Look at the direction of the current. What about 3 ohm? We got 2.1 ampere. Yes, that is true. And the direction of the current? Moving towards left. And the current flowing through 2 ohms? It is 0.833 ampere, otherwise 833 milliampere, which is flowing towards right. So this simulation is what that gives you the values of the current flowing through each resistor, which is matching with our answers that we have done previously. So the method is correct. Okay, now let's do the next problem and let's check whether the simulation results are matching. Okay, here you have a circuit which is slightly complex than the previous one, but let's do this one also. That's what I told before, that after seeing this or watching this video, you should be able to do Kirchhoff's equation in any circuit which is given for you. Okay, so here let's take, you can take any loop. Okay, so randomly I'm taking the first loop as this one. Okay, I'm taking loop number 1 as this one, and the loop number 2 I prefer this one, which is I2 moving in the clockwise direction. Okay, and I3 I am taking this one. The loop number 3 I am taking this one, once again moving in the clockwise direction. Same steps, follow same steps. Loop number 1. Okay, loop number 1, let me reduce this. Fine. Loop number 1, you can see while moving in the clockwise direction, you are seeing the negative end of the battery. So let's write it fast. So you can write 3. Any other voltage source? Yes, we have another voltage source which is 4 volt. You are seeing the negative end. So 3 plus 4 equals resistive terms, right? There are no voltage terms. There are no more voltage terms. So resistive terms, let's start with 2 ohms. 2 ohms, the current flowing through it is I1, so 2 times I1. The 3 ohm resistor, current flowing through it is plus 3 into I1 minus I3. Understood? 4 ohm resistor, current flowing through it is I1 minus I2. Okay, plus 4 into I1 minus I2, because we are writing equation for loop 1, that's why I1 minus I2. Loop 1 is finished. Loop 2. If you move clockwise direction, you can see the positive end of the battery, so minus 4. Okay, moving forward, you can see a negative end of the battery, so plus 5. Moving forward, you can see a negative end of the battery, so plus 6 equals resistors. When you take the resistor 4 ohm, okay, 4 ohm, the current flowing through it will be I2 minus I1, correct? Equals 4 into I2 minus I1. Now, plus, if you take the resistor 5 ohm, okay, here we have 5 ohm, the current flowing through it will be I2 minus I3. So, plus 5 into I2 minus I3. Hope you are getting how to do this. If you move again, you can see 6 ohms, but current flowing through it is only I2, so plus 6 I2. And that's our second equation. That's our second equation. Now, loop number 3. Loop number 3. Is there anything different in loop number 3? Nothing. It's the same procedure. Moving clockwise direction, if you see the positive end of the, you are seeing the negative end of the source first. So 7 volt plus 7. Okay, moving again clockwise direction, you can see the positive end of the 5 volt. So minus 5 equals resistor terms. If you take the first resistor as 8 ohm, then it will be 8 times I3, because the only current flowing through 8 ohms is I3. If you take 5 ohms, then 5 times, see, this is the 5 ohm, you can see current flowing through it will be I3 minus I2, because I2 is opposing from loop 2. Okay, so 5 into I3 minus I2. Understood? Now if you take the 3 ohm resistor, moving in the clockwise direction, I3 minus I1. Understood? So plus 3 into I3 minus I1, which is the third equation. Understood? Now you can solve these 3 equations. Okay, I'm not wasting time for that. I'm directly writing the answers, which is I1 equal to 1.5 ampere. Once you solve this, you get I1 equal to 1.5 ampere, I2 equal to 1.13 ampere, and I3 equal to 0.76 ampere. Now what is our aim? We have to find out the current flowing through each resistor. Understood? So if you take the current flowing through 2 ohms, let's find it out. 2 ohms, where is the 2 ohm resistor? Here. The current flowing through it is only I1, which is in the clockwise direction. So current flowing through 2 ohm will be equal to the value of I1 itself, which is 1.5 ampere. Understood? Similarly, you can write for current flowing through 3 ohm resistor. 3 ohm resistor. Where is 3 ohm? Yes, here we have 3 ohm resistor. Now you have to be careful here. In the 3 ohm resistor, 2 currents are flowing. So let's check those values of 2 currents, I1 as well as I3. Okay, I1 as well as I3. So which current is leading? I mean greater value? I1. I1 is having greater value. So the resultant current will be flowing downwards itself, because the resultant current will be in the direction of the current having the larger value. So answer will be the magnitude of I1 minus absolute value of I3. Anyways, both are positive. So I1 minus I3. Understood? So that current flowing through 3 ohm will be equal to, once you substitute values for I1 minus I3, you get 0.74 ampere. Okay. Now let's find the current flowing through 4 ohm. Okay, we have 4 ohm. Here we have 4 ohm. 4 ohm, the current values, let's see. I1 as well as I2, both are flowing, and I1 is leading. So since both are positive, the resultant direction of the current through 4 ohm will be in the direction of I1. Understood? Because I1 is having larger magnitude than I2. So I1 minus I2 will be the answer for the current flowing through 4 ohm, which will be equal to, substitute the values, that is 1.5 minus 1.13 ampere. You get 0.41 ampere for the current flowing through 4 ohm resistor. Now if you take the next resistor as 5 ohms, the current flowing through 5 ohm will be equal to, okay, the current flowing through 5 ohm, let's see, I2 is flowing in this direction clockwise, I3 is also, I3 you can see it is moving from left to right, so the resultant current will be from right to left because I2 is leading, I2 is greater than I3. You can check the value over here, you get I2 1.13, I3 0.76. So the value of the current flowing through 5 ohm will be equal to magnitude of I2 minus I3, which will be equal to 0.37 ampere. Understood? Now we have two more resistors, which is very easy, current flowing through 6 ohm resistor and current flowing through 8 ohm resistor. Let's find it out. Why it is easy? Because there is only one current flowing through 6 ohm resistor, which is I2, and the current flowing through 8 ohm, you can see it is I3 alone. So the answers will be the values of I2 as well as I3. Current flowing through 6 ohm will be 1.13 ampere itself, and current flowing through 8 ohm will be equals current flow, it is 0.76 ampere, 0.76 ampere in the direction of I2 and I3 itself. That means current flowing through 8 ohm will be from right to left and current flowing through 6 ohm will be from bottom to top in the direction of I2. Okay, now let's compare these values. For that, let me show this page. You can write down the values of the current flowing through each resistor, which is I2, I3, I4, I5, I6 and I8, and let's compare with the simulation results. Here you have the simulation for the circuit which we have done right now, and just check the values of the current flowing through 2 ohm, which is 1.54 ampere, which we have got. Okay, current flowing through 3 ohms, which is a 0.7 ampere over 770 milliampere. Then current flowing through 4 ohm, which is 0.41 ampere we got, it is 404 milliampere, the exact value. And like that, you can just pause the video for a second and you can compare all the values, from which you can understand that the answers which we have got are correct, and it is matching with the results of simulation. Okay, why I'm showing the simulation is because the method what we are choosing, and the method what we have chose is the right method. Okay, and you can proceed with any circuit. Understood? So let's do one last problem and finish this off. So let's do the last problem for today, and here we can take the first loop as this one with current I1, second loop this one with current I2, okay, and the third loop this one with current I3. Okay, by doing problems again and again only you will understand how to solve Kirchhoff's equation, because so many students are having a lot of doubts regarding to solve these kind of circuit problems. Okay, so let's focus on the loop 1. In the loop 1 we have the voltage source with positive end over here, so let's write -4. Okay, we have another positive voltage source, so -1, then another positive symbol here which is -2, and we have a negative end coming up while you are moving in the clockwise direction, so you have to be very careful. You have to put +3. Now put an equal sign. Now let's take the cases of resistors. Let's take the 1 ohm resistor. So 1 into I1, it will be I1. Okay. Let's take the 2 ohm resistor. The current flowing through 2 ohm is I1 only. So plus 2 times I1. Understood? Let's take the 3 ohm resistor. Current flowing through it will be I1 minus I2. So plus 3 into I1 minus I2. Understood? Now if you take the 4 ohm resistor, I1 only flowing, so plus 4 times I1. Understood? That's the first equation. Got it? Now solving the second loop. Second loop, you can see the positive end of the 3 volt, so minus 3. Then again positive end of the 5 volt, so minus 5. Then minus 6, correct? Then plus 7 equals, let's take the resistor 3 ohm first, so 3 into I2 minus I1. Then we can take 5 ohm resistor. So remember, the current flowing through 5 ohm is I2 minus I3. There is a third loop. A part of the third loop is coming here, correct? So I2 minus I3. 5 into I2 minus I3. What about 6 ohm? Here also I2 minus I3, that is 6 into plus 6 into I2 minus I3. 6 into I2 minus I3. Then similarly for 7 ohm also 7 into I2 minus I3. 7 into plus 7 into I2 minus I3, and that's our second equation. Understood? Now what about the third loop, the last loop? In the third loop you can see the voltage source with positive side of the 7 volt while you are moving in the clockwise direction, so minus 6. Understood? Then you can see the negative end of the 6 volt, so plus 6. Negative end of the 5 volt, plus 5. Negative end of the 8 volt over here while you are moving in the clockwise direction. Okay, that is plus 8 equals resistor terms you can see 7 ohm. Let's take the 7 ohm, but this time you are taking the loop 3. So how should you write? Equals 7 into I3 minus I2. Understood? Now what about 6 ohm? 6 into I3 minus I2, because we are writing equations for the loop 3, so this time it is reversed. 6 into I3 minus I2. 5 ohm, it will be plus 5 into I3 minus I2, plus one more resistor is there which is of 8 ohm. Current flowing through it is I3 alone, so plus 8 times I3. That's the third equation. Understood? So you can pause this video and you can solve these 3 equations. That will give you the values. I1 equal to minus 0.39 ampere, I2 equals I2 you will get 0.014 ampere. I3 you will get 0.471 ampere. Understood? Now what you have to do is that you have to find out the values of current flowing through each resistor. Understood? Now I will show you the simulation result and you just check whether your answers are matching with simulation results. Understood? So let's go to the simulation part. So if you have carefully done the problem, then you will get the results like this. Make sure the direction of the current also is correct. So here we have 1 ohm resistor. The current flowing through it is only I1, but the problem is that the value of I1 was negative. Okay, which means the direction which we have chosen was wrong, and we have the direction which we have chosen is wrong, and the correct direction is anti-clockwise direction. That's why current is flowing from right to left. Understood? So like that you have to calculate the values of current through each resistor very carefully so that you get these answers. Understood? So that's how we will do the problems of Kirchhoff's law equation. What you have to do is that you take more problems and then you just solve it out and find out the answers properly. Remember the way in which you have to take the direction of the current and the way you have to subtract, add, all these things. You have to be very careful while doing this Kirchhoff's law, using this Kirchhoff's law method. Okay, so I hope you understood the video. Thank you once again.